Um, let's recap from last week. Last week we talked about data acquisition. That's the last topic. So data acquisition, we touched on land surveying, we touched on remote sensing. No, remote sensing was the topic that we're going to deal with, and we ended it. But we touched on photogrammetry and GPS, and I hope you remember what these technologies were about. So if you were asked to summarize it, how would you go about it? What would you say GPS is? So, Biba, because you are here, yeah, that's the benefit you get. Goto just joined us, yes. So, what would you say GPS is? How would you say to someone who is you've met on the streets that you've learned something about GPS? Like, what do you think? Because it's already on your phone, and the only thing I did was to explain to you exactly what the system is. Are you okay? So, what do you say?
Yeah.
Yeah.
So I would say GPS is a means of technology that help you in directions.
Okay, I think you are trying, isn't it? Yeah. Yeah, you are trying to explain what it is, but I don't think you didn't read about it when you left.
To be
So
honest, I didn't.
it's a
To be
nice
honest, I
try.
didn't.
It's a nice try. But what you need to do is that you don't have to go into exam with the same attitude, otherwise you won't do well. All right. So let's go to Gotthold. Gotthold, what is photogrammetry? For you, I will ask you GPS. What's photogrammetry? Per our lecture last week. Gotthold, are you there? Okay, he's not there, so he's not in the class. He's not present. Okay, let's go to Christian.
Sir, I'm here. I'm here, but the network is worrying me.
Is it because I said you are absent? All of a sudden, your network is working. Okay. All right, so let me hear from you.
I went off first and then. Sir, you said what?
Yeah, so I want to hear you. Let me hear it from you. Okay.
Sir,
Christian, yes. The question is that what is photogrammetry?
Sir, hello, sir.
I'm listening to you, so just carry
Sir.
on.
Okay. So I think it's one of the data sources or acquisition that use also is a technique I think that's used to create a 2-dimension or 3-dimension model from a photography.
Okay, so it makes you. Oh, that's good. That's good. I like the way. I like the way you're going about it. That's good. Yeah. So if you write an exam, it's enough for me to give you, a good mark. So that's good. Keep it up. Christian, we talked about land surveying. What is land surveying, Christian? Christian, you're not here. You're absent.
Hello, sir. I'm here.
Okay, go ahead.
I just connected, sir.
Right. Okay. What is land surveying? And what do we get from land surveying? For GIS, what do we get from land surveying? If you say land surveying is a data source, what data do we get? So don't tell us what land surveying is. Tell us what we get for GIS.
Hello, sir.
Go ahead.
Hello.
Just go on.
Okay. For land surveying, we are able to gather information by use of measurements possibly on the field where you are studying or you are working on.
Right.
And then you can also do that.
So what do you
through
actually,
observation.
what do you get in your hand? What do you get? What would you be paying for if you send someone to go and do a survey, a land survey? What would you be getting to put into the GIS? What would you get?
You'll be getting information that will help you.
No, you not get,
in
normally you
doing
get data.
design.
Data acquisition will give you
Okay,
data.
data that will help you in
So,
doing a design.
no, you just don't add that bit to it. So your answers should be very concise. Don't add the design. You spoil everything with that one. Are you okay? All right. You get data,
Get
but the
the
data you get is
a
actually,
data that
listen to me, listen to me. You get data, but
Okay,
the
sir.
data is locational data. Are you okay?
Okay, sir.
So you will get positions, locations. That's all. You get a lot of it from the as a result of the
XYZ,
lines.
your XYZ coordinate.
Christian, just don't add more to it. That will give you zero. It will not give you a good mark. So
What did you
yeah.
say?
Yes, you get XYZ. You are right on that. Yes. You get XYZ. So that's it. Let your answers be concise. If you don't know it, then it means you don't know it. But if you know it, the answers are very straightforward. So we came to remote sensing. I started talking about remote sensing. I'm going to talk more about remote sensing. But guys, what do you think remote sensing? What would be the difference between remote sensing and GPS? Because I think we talked about that too. That we should draw a line between remote sensing and GPS. What is that the difference between remote sensing and GPS?
One of the differences is both of them, both of them uses satellites in operation. But with remote sensing, you are able to work on a very larger area.
Okay, the coverage is bigger. Yeah, that's true. That's good. And what else? You're able to cover a larger area. What do you get also in your hand? The GPS guy goes out there and uses a GPS. What are they getting? What is the satellite for remote sensing also giving the, whoever is the user, whoever wants the data? What are they getting in their hand? Yes, it can be Christian again, but other people can talk, okay? Sobals, I see you are here. Got told, all of you, the question goes to you. I'm not mentioning names.
You said the differences. When it comes to the remote sensing, you realize that you can pick information and interpret area whereby you don't have a physical contact.
No. You're not answering the question. You see,
you said the difference.
So where were you? Were you listening to us or you were cooking some?
My network is on. No, I'm with you. My network is on and off.
Okay. The network. Okay.
The
So you need to come to. Then you need to come to campus. Goto, you need to come to campus. I'll be looking forward to seeing you next week.
Sir, I am far away to go.
Oh, okay. Then stay there. All right. So Goto, listen again. We want to find out, yes, the difference between photogrammetry, remote sensing and GPS. Both of them use satellites. Are you okay? But they want to know what the two satellites, the differences. Are you okay? And I said the difference can be, we cannot get it from the data that we get from it. To be a good way, a nice way to answer the question. If you look at the products, so what do you get from GPS and what do you get from remote sensing? That's a question. Anybody at all? Let's flow. Let's let it flow.
Hello, sir.
Yes.
With GPS, you can get you get coordinates.
Thank
with
you.
Geometry, you are going.
With remote sensing, what are you going to get?
Going to get the coordinates.
Remote
of the points
sensing.
that.
Texting, remote sensing, Ben, remote sensing, not. You say you're going to get coordinates from remote sensing. No.
GPS. I thought you said GPS.
Okay, but remote sensing, what do you get? What do you get from remote sensing?
Picture.
Ben, are you there? Or are you having network problems?
Say yes, I'm here.
What do you get from remote sensing? Can you tell us, or you can't? You get an image. You get imagery, an image. Imagery,
yes.
image. You get that is the word. That's the key word. Yeah. You get an imagery. Okay. It's like a picture.
Okay.
All right. Okay, that's good. So last week I started describing remote sensing, and then I said that I'm just going over it. So in fact, I'm brushing over. I'm going very quickly than I did last week. There should be a target. The study area is your target. Okay, so if you decide that I'm interested in security issues around the 37 area, and so I need constant monitoring using satellite, then that area, all the objects there become your target. Every single one of them is like a target. The sensor is mounted on the platform. The platform that is housed in is called the satellite. So please, I want you to understand these things clearly so that when you are talking in the exam, you can just write an answer that makes sense. That's all. That's my objective in this class. Nothing more than that. Source of radiation is the sun. The source of the radiation is the sun. Are you okay? So in remote sensing, we have active and then passive sensors. So obviously, the satellites we are talking about in remote at the moment will be a passive one. In other words, it doesn't send its own waves, energy, but rather it measures from the energy from the sun. And you get a reflection of that. Okay. So basically, that's how remote sensing. We sum that up, what I just said, with after the energy has been recorded, you then transmit it to the ground station, and then you now analyze it, and then you apply, you use it. So if it's in agriculture, then you start using it, and you say, oh wow, agriculture is now booming and everything is going okay because of remote sensing. It's okay. So what I just talked about in summary is the 7 processes of remote sensing. Is that okay? It summarizes everything. It's all right. You can see it in pictures. And in fact, this diagram also does a good job. Are you okay? So please ask questions. Otherwise, I'll just move on. Ask questions. I always encourage you to ask questions, please. Please, questions. If you don't ask questions, it means you get it, because obviously what I'm saying makes sense to me, but it may not make sense to you. And so you can ask 1 or 2 questions, but if you are good, I'll move on. And then I'll now go and look for pen and paper to set a question for you in the next coming weeks. Please, I hope we get this one. Let's move on. All right. You can always ask a question as we go. All right, so the original form of remote sensing, I put this image in to just show you.
Question.
Yeah, go ahead.
So does it mean that if there is no sun, the remote sensing cannot work?
Like I said, there are 2 types, of sensors when it comes to remote sensing. We have the active and the passive. Okay, for example, we have what we call the radar. Sometimes they send the signal, the microwave is probably sent to the target, and then it tries to measure it back. Okay, in that case, it didn't need the sun per se. It depended on its own. So for example, you're using radar because it may be nighttime and you need to know what is happening at the airport. You won't go and switch on the sun at night. Are you with me? And most airplanes are landing at that time. I don't know. Do you understand what I just said? Do you get what I'm saying? Yes.
No.
What did you hear me say? Do you know radar?
So,
Do you know radar? Have you heard of radar? Have you been watching movies?
yes,
You know
yes.
radar.
I know,
But all we see is that
Yes, I
green
know
thing
radar.
and there's a blink on it.
Exactly. You see
We
something
see-
going around, it's as if it's scanning the area and then an object is moving and then it can detect it. Most of the time, that is radar. So it's an imagery. Are you okay?
It's
So-
also an image because that one you only see a dot. You don't see, but with the one that we are seeing right now, you can see like green and land.
Exactly.
And
So the thing with the 7 processes of remote sensing requires that there should be analysis. Normally, when you are given an image, you may not be able to see it like this. In fact, sometimes downloading an image like what we are seeing may be very difficult. Even downloading may take an expert to download. So not alone even look at it.
Okay.
Also, bringing it into GIS also requires knowledge. So yes, you just take note of that. What I'm saying is that without a sun, you can store image. You can do imaging. Are you okay? For example, when you go to in the hospital, they have the X-ray, right? The X-ray doesn't need the sun to work, but it takes a picture of you, doesn't it? In fact, those who haven't been to school, when they go to hospital, they say, "I'm going to take a photograph," isn't it? Is that what they say? Or they tell them that go and take a photograph. Is that also? That's imaging. It's the same thing that happens with remote sensing, and then in fact photogrammetry, the same thing happens. So there's a similarity between photogrammetry and remote sensing. There's a similarity between remote sensing and GPS. Take note of the differences, please.
Hello, sir.
Yes, go ahead. Let's talk. Let's have a chat.
If I may pick us back a little, you realize
Oh, it's
that
fine,
in
yeah.
some of the cases too, you hear the surveyors, mostly when they are working with GPS, and they talk about the fact that if the weather is not too clear, it
Yes.
affects
That's right.
the work.
Yes.
Maybe is it because of the satellite and the receiving of the
Exactly.
information from the satellite?
Exactly. Because at that point, in fact, when you even go under a tree canopy, you don't get, a good fix for your position. So what they are trying to do is to get a good fix, which means that you can get a fix, but it may not be good. So if you've actually used
It gives
Uber,
errors.
yes, if you use Uber before, you realize that the driver is sometimes he actually throws away the map that's giving him the direction. Why? Because the GPS is not, the location that is being given is not accurate. So he will now start asking you, do I turn right or left? Now you're asking him, is your map working? Okay, so you are really doing navigation, but then it has to be accurate enough. So when there are clouds, the clouds actually stop the waves, they attenuate the signal. So with GPS, we are not measuring anything from the sun. The signal is being sent from the satellite. Okay, so that's the transmitter. The receivers are us. We are receiving from 3 or 4 satellites in the sky. And then the calculation is being done by our own receiver and it's figuring out. So this GPS is sending a message to your phone that this is my position. The second one is saying this is my position 2. And the other one is saying this is my position. And then what your phone is doing, or the surveyor's GPS is doing, is that it's doing what we call resection. Is that okay?
Okay.
So the resection is a mathematical process which actually allows you to determine the position of an object by making observations to 2 or 3 other objects. So this is surveying. This is basic surveying, land surveying, but then it's being applied so that all the technologies, relate.
Oh,
Yeah.
okay. Thank you, sir.
You're welcome. Any more? Are we good? Any more questions?
Yeah, so what of the total station does?
I think it should come clear. Please, your question has to be clear.
Yeah, based on this satellite case, the total station, what does it work with the satellite as well?
The total station doesn't work with the satellite. Who can tell us how the total station works?
It's just a normal.
The total station, I think it works direct with the target.
What do you measure with the total station? No, the short answer to every question is just, every question has a very short answer. And what is that?
Yeah.
What are we measuring when we stand behind the total station? That's the question. What are we measuring? What are we measuring?
We are measuring distance.
Distances and angles.
We are measuring distance.
And angles.
The coordinates
Yes.
as well.
Distances and angles. That's what we are measuring. Yes. Okay. So I think that answers your question, isn't it? Yes. So this diagram works. You can draw a diagram for all the technologies. Is that okay? So this diagram is for which one is this one? Which technology looks like this? Which technology measures that like this? Excuse me. Which technologies diagram is on the board right now?
Satellite.
Which technology, data acquisition technology, GPS is a technology, total station is a technology, photogrammetry is a technology. I hope we are in here. Yeah, I'm saying, yeah, this is technology. Which one is this one? Which one is this one? This diagram depicts which of the data acquisition methods that we are talking about.
Remote sensing.
Wow. Okay, that is not right, but who thinks he's wrong? Who else thinks he's wrong? Who else thinks he's wrong in the sensing? Yeah?
So what did you say?
He said this is what did he even say? This is remote sensing. Is it remote sensing?
I think it's surveying.
Wow.
No, this is not surveying. No.
Wow.
This is this are satellites. I mean, 3 different satellites.
Then
working on a target.
What technology looks like this? Like the diagram, the board. Which are the data acquisition? How many data acquisition methods have we discussed in this class so far?
3.
How many data acquisition methods have we discussed in this class? And which one of them is this?
These are raster. These are raster data. I think it's raster data.
Please, I haven't mentioned raster in this class. Don't be saying things that you are not. I'm not expecting you to say. But I haven't taught you raster data. If you have satellites, as an engineer, what are the blue lines doing? Are they not telling that there's a connection between the satellites and then the Earth? Isn't it? This is the Earth.
Yes.
So which of the technologies do you have something that sends something to the Earth?
Yeah.
The same location on the Earth. It's what? What are the questions that
Geospatial. I
I
think
asked
something
you?
like geospatial.
Oh, who is this? Don't say things that I haven't thought about. I haven't mentioned geospatial. When you haven't understand remote sensing, you are bringing in different technologies. When you write that in exam, I always give you a bad mark. Don't say things that what we have said in this class, even this afternoon, is enough to answer this. I've just been talking about it. I'm asking you again to check if you can figure out that if you had 3 satellites that are talking to a particular user down there, what technology is that? What's the name?
So the remote sensing.
Land surveying. Yeah. And then GPS, global positioning systems. Which one of them does it look like? Which one of them? 1, 2, 3, 4. Does the diagram look like?
Say the fourth one.
The 4.
So why were you struggling to say that it's GPS? And you were saying someone saying remote sensing and all this. Why? Or the question wasn't clear. Maybe the diagram was looking funny. Eh?
Yeah, I think so, Sadiq. The question wasn't clear.
Okay, I'm sorry. I apologize. In the exam, I'll make it clearer. Okay. Maybe I
All right,
should,
thank you.
should I put an equator? There's some latitudes. All right. So
Global what?
someone is saying global what? Where were you when we were talking about it,
Positioning
my
system.
friend? Someone is asking global what? Where were you?
Yeah, so just to refresh my mind, that's it.
Refresh you should have refreshed your mind before coming. New York. Should I refresh your
I
mind before
said,
coming? When I
it's
teach
you
you and
that
I
I'll
make a
get a
video for
better,
you, and then you are here
it's
asking me
you that
questions.
I'll get a better information from.
It doesn't work that way. Sorry. Prepare for the lecture so that you don't ask questions like that. I like questions, but don't ask questions like that. Okay. I spent time discussing global positioning systems, and I made a video for you. So in the recap, if you can't remember it, humbly make sure in the next lecture, what I talk about today, make me proud. Are you okay? Because I'm spending, how many minutes have I spent on this one? Almost 40 minutes talking about last week. But it's okay. It's normal. Nanaya, don't do that. Anyway, so let's move on. Let's move on. So yeah, so these are all. So the near infrared, thermal infrared, microwave, these are all different parts of the electromagnetic spectrum that we can measure from. So let me just tell you how. So the microwave will be an active system, an active remote sensing system. It will be sending the energy, and then it will now measure it back. But then when you look at the infrared, near infrared, and then we have far infrared and all these other ranges, they are all parts of the electromagnetic spectrum that we can also measure from. I believe the basic science tells us that we have different, ranges of energy values. Are you okay? So in remote sensing, we can take a picture that doesn't look like, that doesn't show buildings per se. We can take a picture of the earth that will show how hot and cold places are. Okay, we can do that. All right, so that is basically it. Also, if you can't collect the data, if you cannot collect the data, primary data source as a primary data source, you can do a secondary kind of thing where someone has already collected the data, then you actually use it. Is that okay? In that case, you need to understand the file types. You need to understand what the file extensions are and what they mean. It's very important. Are you okay? All right, the most important file type in GIS is called a shapefile. Okay, so every shapefile has about 3 or 4 major extensions, file extensions. So if you are saving data on road, you have road, SHP, you have road. Okay, we have 10 minutes. When it cuts, guys, let's rejoin the same link. .dbf, that's a database file, SHP. You can also have road.shx. You can also have, but you realize that the name is the same, the file name is the same, but the extension is changing. .plj. All right, so now you need about 4 files to be present in the same directory before you can actually read it. That is GIS for you. You don't have to ask, that's how it works. It's called the shapefile. So this shapefile is very popular. It's a standard file format that has been accepted. Okay, so take note of that. Let me close. There's a window that's blocking my view. All right, so we can have DBF, like I said, that will be database file, the company's shape files. We have GANZIP, so that's a compressed, file. JPEG, that means you have an imagery. An imagery is a picture. Okay. So we have the JPEG, we have the PNG. So JPEG stands for Joint Photographic Experts Group. So you can imagine that we always say JPEG, JPEG, but we don't even know what a J is, the P. But when you look at a Joint Photographic Experts, the word photographic there is telling you that it's a photograph that you're looking at. DBF, you see that DBF database, it means that when you open it, you'll be seeing data in columns, okay, in there. GANZIP means that you have to unzip it or uncompress it before you can use it. And that means it reduces the size of the file. Okay. Then we have the PLJ, which is actually a projection file. So when you open the PLJ, you get the projection. Now you'll be asking, what is projection? We'll talk about it. It's one topic we have to be. I think the next topic will be that on map projection.
Quick one.
Yes, go for it. Yeah.
The difference between the PNG and the JPEG, they are all graphic images, right?
They all different.
They are all graphic images.
They all give you graphics. Yes, they are all images. They are pictures. Okay. Yes.
But what's the difference?
Basically, there are different alternatives to file extensions. For example, you can have .doc, you can have .docx. They all Word documents. You can also have openorg.writer, which is also for word processing. Are you okay? So it's just they all show you an image. Are you okay? But obviously they will have slide. One will have an advantage over the other. They are quite huge for the application I am doing right now. I don't use this. When someone is doing an app, they don't use this. They are too big. You have to reduce them to WebPG or something. It's a different image format. So they are different image formats. And I won't be asking a question on which one has more weight.
Because sometimes when we download something from the web, sometimes the JPEG or the PNG, and the PNG is mostly smaller than the JPEG.
Exactly. Sometimes, some of them are okay. You can also look at it in terms of, they are what we call the alpha channel in an image. There are different properties of an image. Alpha channel, we can have, compression, lossless compression, so, and we have resolution too. So images have their own properties, and depending on which one you want. Sometimes you may want a PNG or a JPEG, but it's really not our concern. Let me just say, as GIS people at the moment, we are almost going into graphics, which is not what we are our focus is. Our focus is to draw attention to the fact that if someone were giving you that image, what is it? It's a raster image. We talk about raster and vector today. Before we go, we have to talk about raster and vector. All right. So literally, shapefiles save vector data set, and then the JPEG, PNG, the pictures actually are for raster. We are going to talk about raster and vector. I keep touching on them. That means they are coming up. Okay, I'm going to talk about them. All right, so all these are examples of file. There are more of them. I just want to show this to you to explain to you that every file extension, every file that you see has an extension, and the extension speaks of the type of data that file contains, or probably the software that opens the file. Sometimes you can also look at that way. Okay. So yeah, that's that. So these are secondary data sets, not primary. It doesn't matter what they call it, primary or secondary. People like to really talk about it. Like these are primary, they are primary and secondary data sources. Right? I think you need to just know that you can get data, you can build data by going to the field, or you can let someone go to the field and bring you the data, and then you can use it. That's the point being made. Okay. All right. So I guess that ends this particular one. What's happening to the screen? All right. Skip this. Okay. So let's go on to today's major. In fact, we've started today's topics. We just continued. We finished up with remote sensing as a data acquisition method. All right. So I'll be mentioning this word raster, vector, raster, vector. Today, you finally, I'm unraveling it. Are you okay? I've been hyping it and I've been making noise about it. That's how you launch a product. So finally, I'm launching it. Raster and then vector. What are these things? Are you okay? I'm going to talk a lot. I'm going to use terminologies to describe it. But bottom line, if you get into trouble and you don't know what to do, and someone puts you, push you, like someone said, don't push me. But if someone actually pushes you, remember one thing, that vector is points, lines, and polygons. And then raster is simply picture. If you really want to. So what is the raster model? The raster model is actually, when you have a picture of an area, then you have modeled it using the raster model. But we are going to explain exactly in detail what we mean by that. So we're going to start with the raster data structure or the raster data model. Okay, so if you write data structure, I'll give you the mark. If you say data model, I'll give it to you. Okay, so yeah, I'm not going to go into the semantics of it. Hello, boss. Please hold on. I'll be right back.